So during our lecture last week, we talked a lot about macromolecules, which you are hopefully familiar with by now, carbohydrates, lipids, proteins, and nucleic acids. As we spoke about, all of these you need to consume in pretty large quantities to stay alive, except for nucleic acids, which your body makes on its own. These are also known as macronutrients, and they're macro in two ways, or big in two ways. One, the molecules themselves are quite big. They're made up of these large repeating parts. So you have triglycerides and the amino acids that build up proteins and all the simple sugars that build up carbohydrates. You also need them in pretty large quantities, so they're macro in that way as well. You need a lot of them. This week, we're going to shift our focus a little bit to micronutrients, that is, the minerals that are right here. It's interesting to look at the entire composition of the body. So we have about 62% water, and so a lot of oxygen in that water. We have about 16% protein, which makes sense. As we've discussed, protein are really the doers of the body, and so they really do all of the pumping and transporting and um, synthesis that needs to be done in the body. We also have a varying amount of body fat, um, roughly somewhere between 15 and 30% for most people. Um, and we have a little bit of carbohydrates, which makes sense. We need that for storage. And finally, we have this minerals class, and these are broken down a little bit here. Things like potassium and sodium and magnesium. So this week, as I said, we're talking about micronutrients. So they're nutrients that are both physically small. They don't have super complex chemical makeups, but you also don't need very much of them in comparison. So we don't nearly need as much vitamin B by weight as we do carbohydrates, for example. Um, and so this week we're going to be talking about microdeficiency diseases. That is what happens when you don't get enough micronutrients, as well as touching on causal pies and thinking about causal mechanisms of disease. So what happens when somebody doesn't consume the necessary micronutrients? Disease! Surprise! Um, Occasionally death. This shouldn't be surprising to you because micronutrient diseases or microdeficiency diseases are the fourth type of disease we're talking about in this class. So quickly, I wanted to go over the other three diseases that we've already talked about. So we talked about infectious disease, in which case you're exposed to a pathogen and your innate immune system doesn't fight off the pathogen initially, and so you come down with some symptoms related to that disease. We also have physiological diseases, which happens when a problem with the cellular tissue throws off homeostatic mechanisms. So, for instance, if you had lung disease because your lungs were breaking down, if you had diabetes because your beta cells weren't working correctly, your body cannot function as normal. We also have genetic diseases. So it's either a problem with the mechanism of inheritance or a disease that is passed via DNA. For instance, we have something like Turner syndrome, where somebody gets 3 copies of an X chromosome instead of 2, or something like sickle cell that is passed down through an allele from your mother or father. We also have microdeficiency diseases, which we're talking about this week. which happens when somebody doesn't consume or absorb the appropriate nutrients to keep the body running. During this lecture, we're probably primarily be talking about consuming these nutrients, but this is also important for people who cannot absorb them, who, for instance, might have like something like Crohn's disease, or other gastrointestinal issues, so they are not able to absorb all of the nutrients that come in their food. So this means that everybody needs to be eating lots of the perfect amount of vitamins and minerals through all these pills, right? Like everybody should have a um, completely customized to them regimen of exactly how much vitamin A that they need every single day, or else they're going to get disease. No, that's not how this works. Most people get the vitamins and minerals that they need pretty generally through eating a balanced diet. So occasionally this can happen, um, that somebody, for whatever reason, is predisposed to a microdeficiency and might need a supplement. But we do not need to go out of our ways to uh, eat exactly the right amount, exactly the recommended amount every day, or we'll get disease. That's not how it happens for most people. Um, I think a little bit about an example that happened to a friend of mine. She spent an entire summer eating only bagels, so like a bread product and frosting, so like what goes on cakes. And at the end of the summer, she was starting to have symptoms of scurvy, which is a lack of vitamin C. And vitamin C comes from primarily fruits. And it was funny because this is a disease that's normally associated with sailors, or pirates, because they could not come to port for long periods of time, would not have any fruit. And it's really quite a terrible disease. It manifests in really weird ways. Your gums bleed a lot, your hair starts falling out, you have rashes on your skin, you become really tired and irritable. So my friend was having this kind of crazy disease just because she wasn't eating a balanced, nutritious diet, even though she's not a sailor. So we think about micronutrients broken down into two categories: um, vitamins and minerals. So vitamins are named by letter. So we have vitamin A, B, C, D, E, K, and so on. Minerals are primarily elements off the periodic table. So we're going to talk about iron and iodine. You also need fluoride, so things like that. The difference is that vitamins are produced by living things. So, for instance, vitamin A is found plentifully in carrots. And so that carrot is synthesizing that vitamin. So, um, vegetables and fruits make all of the vitamins and minerals that they need. They make or absorb them. They don't need to get them from other spaces like we do. Um, Minerals, on the other hand, originally come from the earth, so they can be absorbed from the soil, for instance. If you're thinking about like spinach has a lot of iron in it. Spinach absorbs from the ground that iron, and then it becomes part of the spinach. Um, but The other difference is that vitamins are pretty chemically unstable. They can be broken down by heat or air or acid. So they are easy to break down by, for instance, cooking. So some vitamins you need to get by eating raw vegetables, whereas minerals maintain their chemical structure since they are basically just metals off of the periodic table. They are able to withstand a lot of changes. So, for instance, you can get iron from eating steak, and the steak comes from the cow, and the cow has eaten the grass. So, the grass that initially pulled up the iron into it is then digested by the cow, and then we kill the cow to eat the cow and cook the meat and have to cook it pretty high. And so there's a lot of heat and air and acid that are in between the grass actually taking up the iron from the ground and us. But since minerals are pretty tough, they maintain their chemical structure, we can still access that iron. So, we're going to talk about three different diseases today. And the first one is called rickets. In adults, this is called osteomalacia. It's a little bit different, and we'll talk about both. And so at the bottom of each of these slides, I have a kind of a diagram of uh, how this comes about. And so rickets happens because of low vitamin D, and vitamin D is involved in calcium deposition and also calcium reabsorption. And so, since calcium affects things like bones in the teeth, then this creates low bone strength and this leads to bone deformities. So, first, let's talk about vitamin D's role in the body. Vitamin D has the role of mineralizing bones in children. So, children's bones are pretty soft, especially while they're growing. Your bones mineralize ending by the time you're about 25. And it also deals with calcium absorption throughout a lifetime. And so we think about calcium absorption as being a particular issue for older people, especially older women, have things like osteoporosis. We're not going to get too far into this diagram, but basically, if you have vitamin D, um, the vitamin D that you eat is going to be dissolved in your intestine. That vitamin D is then going to go into your bloodstream and ends up interacting with your plasma calcium. And this allows for calcium to be deposited into your bone. Then calcium is removed because this needs to be a continuous process. There's also calcium reabsorption from the kidney. Again, don't worry about this too much. Just know that vitamin D helps calcium to do its job, and calcium's job is to deposit onto bones. If we don't have vitamin D, then we have very little vitamin D coming from the intestine to help out the plasma calcium, and we have very little calcium being deposited on the bones, and we have very little calcium reabsorption from the kidneys. But we do still have this calcium removal link, and so you end up with bones that are broken down, which look pretty different than our normal bones. So what ends up happening is in children we get rickets, which is this bending of the legs, and so we call this being bow-legged, and we call this being knock-kneed, um, colloquially. We also have a failure to thrive or a curved spine. Or other kinds of bone deformities. As I said, calcium is also important for the teeth, so we might have dental defects. We might have seizures um, because of the way that calcium um, has a role in synapses. So there are all of these pretty terrible side effects of not getting enough vitamin D. In adults, this leads to osteomalacia, which is similar to rickets in that it's a weakening of the bones. But instead of bending the bones, because adults' bones are no longer growing, they're no longer mineralizing, you just have a weakness of the bones that leads to something that looks a lot like osteoporosis. So in the next part of the lecture, we're going to be talking about two more diseases and causal ties.